Okay, as you dive into this homework, I thought I'd just give you a little kind of recap of some of the stuff you'll see. So I want to remind you that a function, every x, or you could say input, has exactly one y value or output. So there's two ways you can kind of test to something's a function. You can do what they call the vertical line test. And the idea is like if you bring a pencil, like let's say a graph, you bring your pencil across, so you drag it and think about the vertical lines it makes. As long as it touches the graph only once each time, then it is a function. Another way, if you have like a table of values, I usually say to watch out for repeating x values, because anytime your x values repeat, that may not be a function because the inputs, your x value may have more than one y value. So let's take a look here. We're going to look to see if these things are functions and then also talk about domain and range. Domain, I want to remind you, is all the possible x values. And then range is your possible y values. Okay, let's start by looking to see if these first ones, let's just actually go through the whole thing and let's just decide if each of these things are functions. Okay, so on this first one, since we have just some tables of values, I usually look at your x. Since each of the x's are unique, right, and maps to a separate y value, it is a function. Whereas when you look at these x values, do you see I have 1, 2, 3, but then we have 3 again? The fact that you have 2 3s, it is not a function because that input of 3 maps to 4, but it also maps to 2. Okay, think about your vertical lines here. That one you're going to touch 1, 2 spots and multiple places on your graph. As long as it happens at one place, it's not a function. So this graph is not a function. But this last one, as you put those vertical lines in, it's only ever touching one point at a time. So this last one is a function. Okay. Next skill we're going to look at domain. So we're looking at all your x values. When you have a list, it's nice and easy. You actually just list those x values. So 1, 2, 3. And the next one, you use these curly brackets. I think they're usually given to you in your homework, so you're just listing the values, like 1, 2, 3. This next one, it's 1, 2, 3. Even though 3 happens twice, we still only list them once. Okay, this next one, I usually think about with domain, I think about like left to right. So the furthest left, if it goes all the way and it has that arrow, the furthest left it goes, that whole graph will keep going to negative infinities for this left. The furthest right it goes is here at this x value of 2. See how both of these points here go to 2? So we're going to write this in interval notation. I should say domain interval, actually. I guess for this one, maybe, actually, because those other ones were not necessarily an interval. This one's an interval, though. We're starting at negative infinity, and you do comma 2, and that means we're going from negative infinity to 2. Since we're touching at 2, you can think about we're including that point when you do a square bracket. Infinity will always get a parenthesis, but the parenthesis we'll also use when we don't touch the point. So there's like an open circle or something. Okay, this next one. The furthest left they go is here at negative 7. The furthest right we go is 3. So we're going from negative 7, comma, which means 2, 3. Both of those have closed circles, so both of those are going to get a bracket. So for the record, like if this N one was like an open circle, that's when you'd use like a parenthesis. Okay, last but not least, we're going to look at range. So now we're just looking at all your y values. So my y values here are 2, 3, 4. And actually, if you look at these next one, 2, 3, 4, but we got 2 again, it's actually the same exact range. 2, 3, 4, you don't have to list 2 twice. Okay. The lowest it goes, notice this is going down to the left, down to the left, down to the left, down to the left. It will continue. And since it continues all the way, it'll go all the way down, which is negative infinity. This part goes up and to the left, up and to the left, up and to the left. It'll go all the way to the top then, which we call positive infinity. Okay, my lowest point here is at negative 1. My highest point here is at 8. So we're going from negative 1 to 8. Since both of those are points on the graph, we're going to use those brackets. Okay, and it says the graph is shown as time versus distance. So they're just saying, okay, this is time, and this is distance. And we got 2 runners here. Okay, it says which one of these runners is jogging at a constant speed? So remember, a constant speed is going to be something like linear. It's going to be something that's increasing by the same amount every time. So in this case, I'm going to say that red line is the runner jogging at a constant speed. So then, like, who may be kind of starting off and then start sprinting, so they're increasing. Think about, like, they're increasing speed. You can tell that the slope of that blue line, which is going to be a quadratic, is increasing at an increasing rate. So for what interval is the jogger ahead of the sprinter? So the jogger's ahead this whole time. When we talk about that interval, we're talking about the x values. So at 0, they start being ahead, and it ends at 4. So we say from 0 to 4, they're ahead. Okay, last but not least, feel free to do this one on your own, see if you kind of get the idea before you dive into it in your homework. It says the graph of the speed of the third car C, which has an exponential, is shown on the graph of all 3 cars at the same destination. Sorry, I took this problem from another part, and so there was something about cars A and B. But let's go ahead, let's label it for a second. So, I want you to consider for a minute, which of these is linear? So the one that's a straight line is A, right? Okay, as far as the others, you may not be as familiar. It ends up being that B is your quadratic and C is your exponential. I think this is really important. You'll start to see this. When you multiply by things, which is what's happening in an exponential equation, that is always the graph that will kind of overtake the other ones, assuming they're all like positive slopes, for example. So the exponential will always overtake the others because we are multiplying. So it says if the destination corresponds to the distance of 8 miles. Okay, so 8 miles is the distance. So notice here 5, 6, 7, 8. So if this is where we're stopping, which car arrives first? It's car A, right? They're the shortest time because they're like what? Between 8 and 9 and 10 seconds, whereas the other people are beyond 10 seconds. However, if I went all the way up to like 20 miles, so I'm like up here, who won? At that point, then it's that exponential equation. It's part 3. C, sorry. If the 3 cars pass the starting point at the same time and they're racing, would there ever be a point when they tie again? Now when I feel like this graph is not super clear, I think at this point you can kind of see they cross here, they cross here, they cross there. They're just slightly off. I think they're slightly off. But it depends. Like in that one, less than 1 second it's happening, it probably is going to look like they're all crossing. Okay, so what interval is car A ahead? So car A is ahead this whole time, right? From the start up until, I think that's labeling, let's see, that's 5, 6, 7, 8, 9, 10. I think that's 11 seconds. So from 0 to 11. And then car C at that point takes over. So at 11 seconds, car C, we could say, starts. And they'll go for infinity. They'll always be ahead.